All right. Let's get started with, I guess since this is coming from Secure Ideas, I'll talk a little bit about our company. So we were founded in September of 2010, so we finally reached that 5+, or yeah, I guess that's close to close enough to 5 years. So we've survived that long as a small company, which is good. We have basically we're made up of people who have previous experience. So we do a lot of penetration testing now, as well as teaching and architectural assessments, but we have a lot of previous experience in sort of that defensive role. So we have folks in the company who've been the system administrators, who've done those late night troubleshooting type of calls, and then we also have a couple of us, myself included, who've done more of the work on the software development side. So altogether, it's a pretty nice combination that we have, with quite a bit of experience behind us, which is nice. All of us are, I would call, security evangelists. We really, really enjoy what we do, and so we like to talk about it and blog about it and teach about it in situations such as this. So. All right, so let's jump in a little bit on the topic of the day, which is Python. So Python, and by the way, that kind of dot matrixy sort of Python title on the current slide, that was the original Python emblem or icon, which is kind of interesting. So Python is a programming language. It is one thing that's pretty cool about it is that it's evolved around a open source community. A lot of languages, I guess, have over the past 10 or 15 years, but I would say Python was probably one of the first to do this and do it as well as it has, because it came around shortly before the internet. I guess the main author or the catalyst for pulling it all together is Guido van Rossum, and I haven't had any personal conversations with him, but I understand he's still quite involved in the Python project. A little bit of trivia for you. The Python is actually not named after the snake, like you see in all of the books and everything. From my understanding, the story I heard was that it's actually named after the comedy troupe Monty Python, which was popular back in 1989. I guess still is as a sort of a cult following. So the language characteristics of Python, we have. There are lots of things we can talk about with Python, but here are a few that I would like to draw attention to. First of all, it's an interpreted language, so it doesn't have the. It's not. There are advantages and disadvantages to being an interpreted language. One of the advantages is your code cycles are a lot faster. You don't have to push all your code through a compiler, so you can, even for a larger project, you can make some changes somewhere and immediately go back and rerun the program without having to go through a bunch of compilation phases. There are optimizations within Python that are pretty much invisible to the end users. So I won't go into details on those, but it does have the disadvantage of, because it's not compiled, it's not like compiling C. There are going to be certain types of things that will be slower in Python than they would if you wrote them in C. Or some other compiled language. So just keep that in mind. For our purposes, for everything that we're going to do with Python, especially with if you're getting into penetration testing, maybe with the exception if you're trying to do some password cracking algorithms where you might need access to graphic processors, with respect to almost every other task, Python is actually well suited for that, even though it's interpreted. It's an interactive language, and what I mean by that, we're going to be using that a fair bit today. So what that is, basically you can interact directly with the interpreter. So instead of having to write out a program file and then run the file, you can just run commands directly against the interpreter, kind of like interacting with a calculator. So we'll be doing a lot of that, and that also is fantastic for the type of work that we do, because we can quickly test a couple of lines of code without having to write another program to do that. Or if we need to just quickly format, we have a list of items and we want to run through them and do some quick processing on it. It's actually very easy to do that sort of task. For those who haven't experienced it, penetration testing is often an exercise in managing time. So anything we can do to shortcut, get things done a little bit quicker, is usually worth spending some effort in figuring out how to do that. So platform independent, Python will basically, you can install it on Windows. There's Windows installs for it. That's the only operating system where it doesn't, of the main operating systems out there anyway, where it's not already installed. So if you're working on any sort of Linux build, if you're working on a Mac, Python's already there for just about any build. So and the last point I want to draw out is that it is object oriented, and I'll get into a little bit more detail on that near the end of today. But basically, although you can, a lot of what you're going to see in Python is just procedural, just a list of commands or maybe a function that you call a few times. It does have a object-oriented sort of capability as well that is surprisingly simple within Python. So it's that's of course has a lot of power, especially if you are building larger programs. So, by the way, I should mention, if anybody has questions as I'm talking, use the GoToTraining chat, and I'll try to address it. Okay, versions. There are two major versions of Python that are still active, or both actively in use in parallel. We have the 2. Whatever and the 3. Whatever. I still tend to favor sticking with 2. Most of the code that is out there written in Python right now is available in a 2.x version. Even everything that's released for 3 is usually also available in 2. There are some. It's just, I guess, one of the only big failures I know of within Python is its ability to actually migrate everybody up to another major release. It just hasn't really happened. There are some things about the 3.0 version of Python that I'm not going to get into, but there are a large part of the community seems to be resistant to adopting it, and so a lot of the 3.0 functionality was actually backported into the 2.x Python, and as a result of that, we basically just a lot of Python developers will just keep using 2.x Python. Plus, there's a tool for migrating upward anyway. As far as I know, there's nothing for migrating downward from 3 to 2. So if you write your code in using the 2.x syntax, then you should be good to go, and anybody can run it. So, all right. So jumping in to the actual language stuff itself. So we have, first thing I'm going to do is we'll take a look at the interactive interpreter. Very simple. You just get on whatever platform you have that has Python installed on it, and you can type Python from the command line most of the time. It may be different in Windows. I don't regularly use Python on Windows, so I can't really comment on that. And that's it. It'll bring you into an interpreter mode, and I'll show you in a moment what that looks like. You can then print straight to the standard out using a print command. Pretty straightforward. If you type something that Python doesn't understand, it'll give you some kind of meaningful error. I'll show you that in a second as well. The other thing that's probably important to understand is to get out of the interpreter once you're in there, you actually have to type exit as if it's a function, so with the open and close brackets on there. So that's the basics of the interpreter. Expressions. Basically, expressions are going to be very straightforward. If you've done any sort of programming in any other language, it's probably going to make a lot of sense to you. You have an expression and then an operator and then another expression. That's how you're going to do. For example, look at the examples at the bottom of this slide here, and you'll see it's very math-like, I guess. I'll go through the operators that are available actually. So if there are a lot more than what are on the screen. I just wanted to cover some of the basics. So math, you have your usuals. You're going to have your ability to add, subtract, multiply, and divide. If you're doing whole division, that is, you just care about the whole number of the result of the division, not the remainder. It's actually just a double slash, so double divide. To get the other part, the remainder or the modulo, it's going to be the percent sign that you're going to use for that. And unlike a lot of languages, the syntax for doing a power of it's not the caret sign. It's actually asterisk asterisk. So that's it for the main math stuff. Logical operators. You have, of course, the usual greater than, less than, greater than equal to, less than equal to. Equals, as in if you're determining an equivalence, is a double equal sign, and the opposite of that, the not equals, is going to be exclamation point equals. There's also a logical and, but one thing that you're going to notice if you're new to Python is that a lot of the operations that are built in there are actually closer to natural language than other programming languages. So we have and, or, and not that are just expressed using those words, and, or, and not. There are some other ones too, and we'll see some of those later. There's also in-place operators. So a big example of that one is the ability to increment or decrement. This is used quite often. So you'll see in this example here we have a equals 0. And then instead of writing a equals a plus 1, what we'll do is we'll write a plus equals 1. And in this example, because the variable that we're looking at, a, is just one character long, you don't really see any huge benefit to doing this. But if you consider that if you're referencing a complex data structure, you don't want to have to type it out twice on the same line. So this way you only have to type it out one time. Okay. Variables, again, really straightforward. You can use, and most words will work. The name itself of the variable is comprised of letters, numbers, and underscores. It can't actually, you can't start with an underscore, though. That actually has special meaning in Python. So the naming convention that we typically adopt for variables in Python is all lowercase with underscores separating words. Okay. So with that said, let me jump over to interactive interpreter, and we'll open it up and take a look at a few things. Alright, so hopefully everyone can see this. What I have here, this is just a pretty vanilla Ubuntu install. I've added a couple of the Python IDEs on here, and I'll talk about those a little bit later. And that's pretty much it that's been added. So like I said, if you want to start working on Python, all you need to do is type in Python, and you'll come into this kind of environment here. And this is an interpreter. You can feed it commands. Anytime you anytime you get a return value and it's not assigned to a variable, the interpreter will output it in this particular mode. So if I do, for example, 2 times 21, 2 times 21, and hit enter, it's going to basically behave like a calculator. Okay. Strings is another one. If I type, just a string Python, it's going to respond with whatever the value of that is. So, setting variables. You can. I should probably make this a little bigger. There we go. And then if I just want to see the value of a variable, I'm just going to type that variable and hit enter. Right? That makes sense. Okay. Oops. One second. Get back to my presentation here. Okay, so a question was, how do you clear a variable? That's a good point. Let me go ahead and show that. So if you're going to clear a variable, Python has a special, like an equivalent of null in other languages called none with a capital N. So if I do x equals none, that's the same thing as saying, okay, well, we're basically saying x no longer has a value, because now if I type x, I don't get anything back. And you can use that that keyword none to test as well if a variable has been set. And you'll see that a lot in Python code as well. Good question. All right, let's get into the next section here. I actually have quite a bit of ground to cover and not a whole lot of time, because I'm trying to keep this so that it doesn't go too long. So comments, single line comments, they start with the hash sign, or I think in America they still call that pound sometimes. There's also something, multi-line comments, that can use single quotes for that. By convention, though, you almost never actually see that, because that has special meaning in certain contexts around object-oriented. So my advice is to, for the most part, for your comments, just stick with the hash symbols at the beginnings of lines. That's going to be familiar to anybody reading it. So. Files, really straightforward. Okay, so here's a very simple file that just has a couple of lines that it prints out. The extension, of course, is .py. You have a header. It will still run without the header. This is a convention that's used if you do want to make a Python file executable. Then you should definitely include this. But what you're basically doing is you're giving it the path to the Python binary. And then, so we have a comment in here, and then we're printing a string, and then we're printing a value. And in the bottom right, you can see that's how you basically run it. You just type Python space and then the name of the file, and then it's going to go ahead and run that file. So really straightforward. So Python files, as you saw in the previous example, they're basically just text files. They're not formatted in any super special way. But using an IDE, especially if you're doing any large amount of code or if you have several blocks of code and multiple functions, it gets a whole lot easier if you use one of the IDEs that are out there. They'll have syntax checking in there, colorize functions, some smart completion. So it's a really good option. A really good idea to go ahead and consider using an IDE. There are several different IDE options out there, and some you have to pay for. I've listed 3 that are free, or at least there are free versions of them. So idle is kind of the de facto standard. Sometimes it will already be installed on certain OSs. It's free and relatively easy to install if you don't have it. And I actually have that in the, I'll show it to you in a second, in the Ubuntu environment I'm running. Also Komodo out there. I think I tried it, but I haven't done any development in Komodo. But I know that it ranks up there in terms of popularity as well. PyCharm is the JetBrains solution. So if you're already familiar with some of their other IDEs, particularly around IntelliJ IDEA, then PyCharm will seem extremely familiar because it's basically the same interface. So. And they have a community edition, which it does have some limitations on certain types of library support and a few other things, but for day-to-day programming in Python, I actually prefer that one. It's pretty good. So. All right. Okay, so strings. We use strings a lot. Python is actually very good for manipulating strings. When you're doing any sort of penetration testing, this is an area where the use of strings is something that's very commonly used. We'll be parsing a lot of things. We'll be sending payloads that come from lists of strings. Be dealing with large, text files, logs, web input, output. Just a lot of what we deal with is strings. And fortunately for us, this is one of the other reasons that Python is really great for pen testing, is that it has fantastic string support. So I'll go through a little bit of that now. This is where a lot of the really powerful stuff is. Even if you're just writing like 2 or 3 lines of Python to process a file, this is where you're gonna find a lot of benefit. So they can be, first of all, they can be enclosed in single or double quotes. So you can use single quotes or double quotes, but if you have the same quote obviously inside the string somewhere, you're going to have to escape it. So I don't know that anyone's really adopted a particular convention, whether they always do single quotes or always do double quotes. It seems to be up to the individual from what I've seen. My preference is I usually use single quotes unless I have a single quote inside my string somewhere, in which case I'll use a double quote so I don't have to escape anything. So it's flexible. You can operate on strings. So concatenating strings in Python is you just use plus. So there, I have an example there, hello Python. You put those two together, you get hello Python. If you are concatenating some other type of data that is not a string itself, then you can use the str function. I have that on here to convert it to a string so that it can be concatenated. You cannot concatenate non-strings to strings. It has to be converted to a string, or you'll see an error. Another interesting thing with Python, and I don't remember seeing this in any other languages, but you can actually multiply a string in order to make it in order to display that same string multiple times. So in this case here, I have the exclamation point 10 times, and so it shows up 10 times down below. So that can come in handy in certain cases as well. All right, so now we start getting into some of the really cool stuff, the indexing of strings. So basically, Python treats a string as an array of characters. And so you can reference anything inside that array just by using a square bracket representation that's common with a lot of other languages for representing an index inside of an array. And so it just basically works on the string the same way. So that's kind of interesting. One thing that's a little bit different than an array, though, is the referencing from the back end. So if you use a negative number, it will index from the back end of the string towards the front. So in this case here, Python with index -2 is going to count from the back, so it's going to be n and then o. So o is what will be displayed. And then if you try to, of course, index something that's not inside the range, then you will get a string index out of range error. I will point out that Python does index from 0. So if you use, in that very first example there, notice that it's a 0 and not a 1 to reference the P, the first character on there. Okay, now similar to indexing characters within a string, there is something called a slice, or a substring. And what we do here is we can actually pull out a portion of a string simply by similar to indexing a single character, we just give it 2 parts, and we separate that with a colon. So the first one indicates the beginning of the string, and the second one indicates the end of the string. Now, this might seem a little bit counterintuitive at first, but the start character position is actually included in what gets returned, but the end character position is not. And what this results in by doing it this way is if you've programmed in other languages where you've had where you've been pulling strings out of other strings, you may have noticed you often end up in situations where you have to subtract 1 from an index because it's not returning the right number of characters from the string that you want. Surprisingly, this approach inside of Python usually avoids that situation. So you almost never end up having to add or subtract from indices just because of the number of characters being returned being not quite fitting the convention. So on the bottom here, I show 2 examples of where if you completely omit one of the boundaries, it just picks the end of. That's what that means, either the start or the end of. So in that first one, I have :3, so it's going to pick the first. It's going to return positions 0, 1, and 2. So we have PYT in that case. And for the last one, it's going to return positions 3, 4, and 5. So hence the HON return there. All right. A few more things. There is such a thing as negative slicing as well. So again, it just indexes from the end. And there's also another interesting there's actually a third parameter that was added to the slicing syntax later on. It wasn't a part of the original spec, but it's in the latest few versions of Python. And what it does is it's a step parameter. So in this case here, we have Python starting with character at position 1. The second parameter on that slice. Let me use my mouse here. The second parameter here is empty, so that means use the rest of the string. And then we have a step of 2. So what that's going to do is it's going to pick the Y, the H, and the N, because it's taking a step of 2. By default, it would be step 1, and we've told it that it's 2, so it's going to actually skip every other character. Okay, there's a find method or function on strings. So that's how you find something, and it will return the index of the beginning of whatever you're asking for. And you can also, as a second parameter to find, you can specify a starting location, starting index for that search. So that's for searching across strings. Okay. Another interesting thing to look at that has to do with strings is the concept of formatted strings. So you can take basically we use this special syntax, the % and then a placeholder, which is going to be the type, the data type that's going to be inserted, and what we'll do is oh, hang on, what's the second? If the pattern is repeated, would return the second, third, etc. I'm not sure exactly what you mean, but I'll probably have it explained in a moment. So basically, it's a placeholder for where you're going to put your input. So this allows you to basically construct a string where you're just going to make changes to certain parts of the string. Multiple variables can be substituted. For that, we're going to use a tuple. So here's the syntax for a tuple. Of course, we have a open bracket, close bracket, and the two values in there. So it's basically a list of responses in there. Okay, so other placeholders. There are more than what's on this list, but this is probably far more than you'll use day to day anyway. So %s is going to be the most common one. This is converting it into a string value. I will sometimes use %i's as well if you have integers that you're putting in there. And if you do need a % sign somewhere in a formatted string, you have to escape it by doing %%. Alright, so let's take a quick look at some string stuff. Let's see how that works. So first of all, I do want to mention here's the IDEs. So if I open up idle, for example, an interesting thing about idle is it actually puts you into an interpreted mode first, and it does have the concept of colorizations built in even in the interpreter. That's what I was trying to say. So if I say, hey, I want to just look at the character position 2, you'll see where the string is actually color-coded green, and then the index is in black. And I don't know if you can see it on the video, but the response here actually came back blue. So if I do Python 2 to the end, then it'll do the rest. The rest of the string gets returned. Also, looking at formatting. If you only have one position that's in the formatted string, then you don't need to return a tuple. I actually did this. I need to actually return this as a string as well. There we go. So that's what we're going to get there. If I do have more than one, hang on a second. There we go. Then, like I said, we need a tuple. Right. Okay, lists. So we're going to talk about a couple of data structures now. We're going to talk about lists and dictionaries. So lists in Python, so these are kind of like arrays of items. The types of items you put in a list can be anything. Python's not very strongly typed. It doesn't really care what you put in that list. And you can mix and match inside the list too. So like I have in my example down here, I have t equals, and I have a couple of strings in there, and then I have an integer thrown into the middle of it, and that's Python's perfectly okay with that. So it's an ordered list of items, and it behaves with respect to indexing and slicing almost identical to the way that strings do. So, for example, so down here we have a string that's made up of 5 characters, and if we try to return the 0th character, we're going to get that returned as a string. In the case of a list, we have 5 items in this list, t, and if we return the first one, it's going to return whatever that is. So in this case, it is a string, so it's going to return that as a string. If it was an integer, it would return an integer. And the slicing works the same way too. So 1 through 3, that means return the second and third item. Remember, because we're indexed at 0, so and this does the same thing. It's the second and third item in the list gets returned. So okay, so that's basics for lists. They're used a lot, so we'll be spending a fair bit of time on lists. The other thing to keep in mind is that you can put lists inside of lists, and that is essentially how in Python you can have functionality that's similar to a multi-dimensional array for those who come from who have experience in some of the more mature languages out there. So basically, if you look at the very last line on here, you can see where I'm referencing an item inside of a list, or an item inside of a list inside of a list. So it's that two-dimensional array basically, and the syntax is very similar. So okay. All right. So I want to spend a little bit of time actually doing lists inside of our interpreter here. Play around with those. I think I'll just minimize that for now. All right, so let's say we have a list called, I'll just call it my list, and we'll give it some values here. So we'll say milk, juice, bread, it's my shopping list. Okay, and of course, if I just look at what the results of what's inside my list right now, we have milk, juice, and bread, so it's 3 items. There is a way for us to tell exactly how many items are in there. There's a function, a built-in function called len for length, that returns the length of the list, how many items are in that list. And that's len works with other things too. You can do length of a string with that function as well. You can use the in keyword to determine if something is actually in a list. So if I can say, is apples in my list? And it's going to return false. And I'll point out very quickly now that the Boolean values true and false in Python begin with a capital letter. It is case sensitive. So apples are not in my list, so let's say I want to add apples to my list. So how do I add to a list? There's an append keyword, or append function, sorry. So I can append apples to my list. Now if I look at my list, I have milk, juice, bread, and apples. It added it to the end of the list. Remember, this is an ordered list. You can also insert into a list. So let's say I really like apples, so I'm going to insert into the second position more apples. I think I did this right. Right. So now we have milk, apples, juice, bread, and more apples. Okay. Oh, so there's a question: can you sort sort the list? There is a way to do that, and let me just see. It might be no. I can't remember right offhand exactly how to do it. So, but yeah, there is a way to sort the list. In fact, depending on what type of data is inside the list, there's a very I don't want to say complex, but a very powerful method of doing that, where you can, for example, let's say you have a list with certain objects on there, and you want to sort based on a particular field within those objects, some member of the object. There's a way to actually do that inside of Python as well. So, yeah, I didn't. Did that actually put it in order? It did. Okay. So that'll go with the default. So there is a dot sort on the list. Okay. Let me look at. Oh yeah, count. I want to do this one as well. So let's say you have a really long list and you want to know how many of a certain item are in there. You can use count on that. So in this case here, I want to see how many times apples are in there. It's going to say 2. There's a dot index. So if you're looking for the first occurrence of something, what index in the list is it? Red. So is at index 2. So if I look at, those are going to be basically opposite operations there. You can remove an item from a list by specifying the item. So if I remove apples, actually it's probably not the best example since we have 2 at the beginning. I'll remove bread. So now we have apples, juice, and milk. And the last function I want to show is pop, because it has some powerful implications here. So I've typed mylist.pop, and notice it immediately returned the last item on the list. It actually removes that last item as well. So just by having that one function on there, we now have basically a first in, last out stack that we can make use of for all kinds of purposes. So, all right. So we did lists. So we have ordered items in a list. Dictionaries, that's where we get our key value pairs. Okay, so it's not ordered. It keeps basically the keys, each key's unique within the dictionary. In other languages, this might be called hash map or a I'm trying to think of other things. I can't offhand, but a hash map is another one. So basically, it's going to keep track of these key value pairs. The key can be a lot of things. You can, but I mean, most often that what you're going to see is the key is usually strings in there, and sometimes you'll find it's actual objects of whatever type. So there's 2 ways to retrieve values from a dictionary. The first is to reference it kind of the same way that we reference an index inside of an array. So we're going to use the square brackets for that. The second one is to use get. So there's a function called get on there. I prefer to use the second one because using that function, it will actually not throw an exception if the value is not in there. It'll just return none. And it will, you can provide a second parameter which has a default value that'll get returned. So usually when you use get, you'll find that your code is a little more concise. Same way as in a list, we can actually check a dictionary to see if a particular key is in there using the keyword in. So we can add a new key just by almost the same way that we do with lists. So we're going to have open brackets, and then you'll specify the key, and then equals, and then whatever the value is. If you specify a key that's already in there, it's going to update the existing value. So each key in the same dictionary is unique. If you try to reuse it, it'll just overwrite whatever the value is on there. You can get a list of the keys. You can delete a key. Delete is a little bit odd in that it's not a function. It's kind of this special keyword. So you just del and then space and then whatever it is. And that'll remove the key and its value as well. So lists can contain dictionaries. Dictionaries can contain lists. And that's basically how we store and manipulate information inside of Python. So it's a combination primarily of those two data structures and mixing and matching various different ways. So if you're going to be writing code in Python, you're going to be probably spending a fair bit of time getting familiar with both of those. So we'll take a quick look at some dictionaries, and I'll show you a few other functions they have as well. So let's see here. I'll call it me. So a dictionary is just defined as empty curly brackets if you're just starting off with an empty dictionary, or you can immediately put some values in there. So I might say my name is, well, let's say first name. First name is Jason. My last name is Gillam. And now if I look at the values, notice it didn't keep them in order. It doesn't. It has its own way of organizing the data internally, and the order doesn't really matter. So if I wanted to return something, I would basically just specify. This is the one way of doing it. The other way would be using get. So I can. Whoops. One second. Name isn't in there because I didn't put that in. So last name, or I can do, like I said before, a .get, and then a value. Right. And get can, let's go back to name again. You can specify a default value with this one, like I said. So I could say, like this, get name, and because name is not actually defined, I've only defined first name and last name, nobody would be returned because that's what I said is the default value. A lot of the same functions that are available inside of lists also work in with dictionaries as well. So we can return the length of the dictionary, so how many entries are there in there. We can use in, like I said, to determine if something's in there. Name, as we said, is not in there. And of course, if we want to remove something, we do use delete. If we want to add another value on there, like let's say, oh, I know. I don't have Twitter. I don't have Twitter in there, so I want to add Twitter. So my Twitter handle. All right. So now if I look at me, it's going to include Twitter in there as well. So. Okay. Let me head back. Tuples, I just want to take a second to talk about tuples, which is basically it's a data structure you're going to see. It's basically an immutable list, meaning you can't add or remove anything from it. It's basically just set as a way to move multiple pieces of data around together. So, for example, maybe it's the input to certain functions. You might have things that belong together. One place where you find that that immediately comes to mind a lot for pen testing is when you're opening a socket, you're going to give it the host and the port together as one group of data. Even though there's two pieces there, they're not two parameters when they're passed in. They're actually passed in as a tuple. So it's two different pieces of data that belong together. Okay, blocks. And we are getting near the end of what I have. So blocks inside of Python. Basically, you're going to have whatever your expression is, and then it's going to end in a colon. Okay, and that defines, hey, this is the beginning of a block. The block itself, Python doesn't use brackets or anything like that to determine where a block begins and ends. What it uses is space, white space. So at the beginning, you'll notice in this example here, the second two lines are indented. Those belong to that block, whatever that expression is above. Okay. The space itself, by convention, we tend to just use spaces and not tabs. Whatever you do, don't mix and match tabs and spaces in the same file. Python will get confused. And so will anybody else opening up your program. So the best thing to do, by convention, most Python programmers will use just spaces. They'll never use tabs. And usually we use 4. You can use a different number as long as you're consistent. So you can get away with 2 if you want to make your code a little bit, shrink it down a little bit. But I wouldn't recommend going down to 1. It just gets really hard to read. But most people will use 4 spaces. When you stop indenting to that and you go back to that same level, that's how you indicate that, hey, this block is done. So this is a way of organizing our code, blocks. So we have loops that go into blocks. We have conditionals, and we have procedures. So let's look at a couple different types of loops. First, there's a while loop. So while there's some type of condition, then keep iterating over this loop. Really important because this happens. Everybody does this at least once. Is you do something like you have a value that you mean to increment, and then for whatever reason you forget to increment it, and then you end up with this loop that just never ends. It just keeps going forever. Make sure that if you're, especially with while loops, that you have a condition in place that's possible to actually exit the loop. The other type of loop, which is I find it a lot more common in Python programs, are for loops. For loops are for iterating over things, which is often what we're doing. We're iterating over values in a list, keys in a dictionary, lines in a file, or just values in a particular range. So this is a very extremely common function. So on this example here, I have a work week made up of Monday through Friday, and for each day in the work week, print out the day. And that's all it's going to do is print out Monday, Tuesday, Wednesday, Thursday, Friday, each on a separate line. You can also use the range. So I have that example on the bottom for x in range 1 through 10. And that also behaves similar to the way the indexing does with the slices I talked about earlier. So this will actually print 1, 2, 3, 4, 5, 6, 7, 8, and 9. It won't print the last one. Okay. Since I'm running a little bit short on time, I think I will skip over the examples for this one here. And I can circle back on those later if somebody wants to see them. Exception handling. So Python does have exceptions. I mentioned earlier that you can say if you for example, reference an index that's outside of the bounds, then it's going to give you an exception for that. In this case here, in this example, we have a number divided by 0, so that's going to be, it's going to throw an exception, basically an error message. So you can catch those with a try except block. So we're still talking about blocks. In that way you have a way to actually handle gracefully, what you want the code to do when that exception occurs. There's also the concept, I don't have it in the example here, but you can also have the finally block. So you can have try, except, and then finally. Finally gets run no matter what, whether the code completes the try block or if it goes into the except block. And that's where you're going to do things like, let's say you have a file handle open, you need to close the file. So that's a good place to do that sort of thing. And close out any resources. Procedures or functions or whatever you want to call them. Basically, there are reusable blocks of code. So there are a bunch of functions built in. We've already looked at several of them when we looked at len or find or sort earlier. All of those are functions. So we can actually define our own. And the grammar for that's really straightforward. It's just the keyword def, D-E-F, space, the name of the function, and then in brackets any parameters that you want to pass in. You can return values from a function. Notice I said values. In Python, you can return either a single value or multiple separated by commas. Okay. Conditional blocks. Sometimes we want some code to only run if a certain condition is true or if a certain condition is false. Basically, we're going to use the if keyword for that. If an expression and whatever your condition is, and then you have your block there. So let me just go on to a more meaningful example here. So we have if, and then there's for some reason in Python they felt it necessary to shorten else if down to elif because that saves 2 characters. So we have if and then elif if you want to have measure a particular condition, and then under a different condition you want to do something, and then under another condition you want to do something else, and then you can end that off with an else. So if none of the above conditions are true, then do this. So that should make sense there. And let me just pull out one more example here. So let's say we want a function that will tell us whether or not a value is a palindrome. So you know how palindrome is, that's a word that spells the same way forward as backward. Should have picked a shorter word. So we'll just call it a word. And what we're going to do is we'll just return. I'll use some conditionals in here so we can practice them. We could shorten it, but if word is equal to now here's an interesting. I wanted to do this one also because it kind of shows an interesting use of indexing here. So what we're saying here is we're creating a slice of whatever word we put in there using the whole word, so the beginning and the end of the word, beginning through the end of the word, but we're doing step -1, which means it's going to do it backwards. So if the word is equal to the word backwards, then what we'll do is return true, else return false. Okay, so now we have this defined. So if I do I'm going to call my function now that it's defined. and I'll just use my name. That should return false. I use another word that I know is a palindrome, level. Oops, what did I do? I spelt it wrong. There we go. It returns true. So, all right. Okay, I know we're running a little bit over. I do have one last section that I'd like to cover, because this is something that if you're getting into Python, you probably really want to know how to do, which is how do you open a file and get access to that, or how you write information back out to a file. And in Python, it's really easy to do, so this won't take very long at all to cover. Basically, there's a built-in function called open. So what we're doing here is we want to specify it as two parameters. The first is the file path. This is a file in the current path, obviously, because it doesn't have any slashes or anything. And then we specify the second parameter, which is going to be a string indicating what mode of operation we're opening that file in. And the three basic modes, there are some other modes as well, but the three basic modes that we're going to use with text files are read, write, and append. And that's basically how it is. This F here, so whatever variable we're pointing this at, that's basically a file handle. It's a way of referencing that file once it's been opened. So reading from a file, we're going to use the R mode for read, really straightforward. You can read an entire file contents just by typing, once you have the file open, you do f.read. Very, very straightforward there. What's probably more useful, though, instead of just reading all the contents in, is to read them into a list of lines. So basically using the line separators, Python will automatically just put this into a list so that we have a separate item in that list for each line in the file. And then we never want to forget to close out the file handle when we're done, so f.close afterwards. Now, in a lot of cases, you might be looking at a situation where you have potentially very, very large files. Maybe it's a massive log file or something along those lines that you need to read in. If you're going to do that, it might not be practical to read all of that file into memory inside of Python at the same time, especially if you're talking about hundreds of megs of data. So Python has an interesting and very specific way of iterating over the lines of a file without loading the entire file into memory all at once. So this is the syntax for this. This is kind of, I consider this magic syntax because it's a little bit different than the way that we do other things inside of Python. And I mean, if you're doing it on a regular basis, it'll just make sense to you. But so it's with open. So we're talking. It's the same basic syntax for that open command, but it's with we use the keyword with open as f. So that f is the file handle again, and then we can iterate over for line in f. So then we're doing something with that line. Okay. So the with statement, by putting it in this form, with will automatically handle the opening of the file, but also the closing of the file. So that's one thing we don't have to worry about. It will close out the file automatically when it's finished iterating over the contents. The way that the for statement works in there is it basically handles the buffered input-output. So it will load chunks of data from the file as needed, and then we process them, and then it'll load more and basically keep going, so on and so forth, and just load what it needs. So again, this is a good way to iterate over a larger file, without loading the entire thing into memory all at once. Writing to a file is almost the same. It's just kind of slightly different syntax. So file equals open. Oh, the open part's exactly the same. We just specify the W as the mode of operation, and then we can start writing lines. We can start writing text, I should say. It doesn't automatically include the a new line, so you have to add that in if you want to add lines. Or if you already have a list, you can, just like there's a read lines to read in a list, there's a write lines to read, to write a list of strings back out. In that case, it will actually add the new line. And same thing as before, don't forget to close your file when you're done. Appending is just like writing to a file. The only difference is when you're appending, of course, it's not going to overwrite the file. So if you just open it in write mode, it will truncate an existing file and write from the beginning again. So, question: how does using with open versus the other method compare for speed, assuming memory isn't an issue? I actually haven't done the comparison myself, so I'm not entirely sure. But my guess is, I'll just back up a little bit here. So, so what we're talking about is, the performance-wise, is this provide better performance than just reading everything in? My guess is that in general, if memory is not an issue, reading everything in at once is most likely going to perform better, just because there's no we're not going through iteration loops while we're also reading off of the file system. So it's basically just, hey, let's read everything in at once. So basically blocking until we read it all in, and then we can process all of it. But by then everything's in memory, so it's not having to go off the disk again. So you're basically greatly reducing your disk operations. So definitely for smaller lists of items or smaller amounts of content, and I don't know really how to qualify what I mean by that, but if you're not talking about like hundreds of megs and you're okay with reading the whole thing in a memory, this is usually the way that we do it. So. All right. I'm going to skip over the files. I will say everything I've talked about so far, all of this stuff, there are tons of examples. One of the greatest things about Python I didn't mention at the beginning is that it is extremely well documented through the community. So if you're looking for an example, hey, how do I write a string to a file in Python, you just type that into your search engine, and you'll probably come up with a dozen examples of how to do that. So it's very well documented. There's lots and lots of information out there. So object-oriented design, there's minimal changes in the syntax and the semantics for going from the procedural stuff that we've looked at so far to actually writing this around classes and objects. All we really need to do is we define a class. Again, class is just basically another block, only we give it a name. The naming convention changes with object-oriented. Now we actually do use capitals, usually. And then you can define members of that class. So here I have a member called kind, and I have a function in this case here, init, and that's actually has special meaning. And we'll see down here we've defined two objects, two dogs, one called Fido and the other one called Buddy. So there's a couple of keywords we just saw. One was self. You'll notice every single function inside of a class always has the self parameter. You don't specify that when you call it from outside. But, like for example, here I have a call for a bar 1. You notice I didn't pass anything in for self. That's implied. It basically says this is a way to reference this particular instance inside of itself. So it kind of means what it says. You'll also notice, I just want to point out that it defines a scope as well. So we have bar 1, which just returns x, defined inside of foo. We have bar2, which returns self.x. Okay, so x is defined in more than one place. It's defined as an input here, and it's also defined as part of the class, as a member. So in this case here, where it's the input, we're returning just x, which means it's just referring to the local version of x. Whereas here we're returning the actual instance member. That's where the self comes in. That's why self is important. So in this case here, it's going to say self. Oh, you mean this x up here? So I'm going to return that, and we can see that down here where we've executed these. And then the other kind of special syntax that you're going to see is that the special underscore underscore init underscore underscore function, which is that's your constructor method. So anything that you want to pass in as a parameter when you construct a new object, that's where you're going to define that. That's where you're going to define any sort of initialization code for that object. You can also specify, just like anywhere else, I know we didn't cover this earlier, but functions can have defaults. In this case here, the init has a default type of MUT. So if I don't specify, like this first one here, we have d equals dog Fido, the type for Fido is probably going to be MUT. That'll be the default. And then Buddy here is an actual a corgi. Buddy's a purebred, I guess. All right, so that's it. That's all I have. Sorry, I went a little bit over, but hopefully this was helpful for some of you. Get you on your way to writing some Python code. I do want to mention a couple things right quick. First of all I've done so far is just go over some of the foundational bits on how the language itself works. These are the pieces that I find the most important to understand. So there's a lot more that you can do. Python is wonderful in that it has really great support for a lot of things already built in. People have already written a lot of modules for things. So there's a lot of standard libraries for accessing system information, for doing networking. There's tons of networking capabilities built in. There's hashing built in, and things for time, parsing of JSON, XML, even HTML is all built in. Those have all become standard libraries over time. There is also a user interface library as well that's built in. There's also a ton of add-on modules, and the count for those is somewhere. Last I checked, which was about a year ago, there were over 40,000 third-party libraries basically that have been contributed to Python. So if you're writing code in Python, chances are there's a very good chance that somebody else has already written at least some of that code. So you'll be able to reuse a lot of what's out there. And I will go back and circle back on any other questions once I get to my last slide here. I do want to point out we have some upcoming classes and webcasts. So we have Professional Evil training in October in Austin. So check out our website for that. There's a bunch of different training on there, including a Python for Hackers that's going to go over a lot more than what I've covered today. And it'll be face-to-face, so it'll be probably a much more inclusive environment, I guess, for learning. And then we have B-Sides Asheville this weekend. On Friday, I'm doing a Python hacking workshop, so that's just a 2 or 3 hour thing. And then we have other webcasts coming up as well. So keep an eye on our website, get on our newsletter, get on our Twitter, and you'll see we have PCI for small business. I'm going to be doing one on building burp extensions in a few weeks. We also have one of our guys going over Metasploit, so kind of getting started with Metasploit would be kind of cool, and then and another one on going beyond just basic shell. So those are all pretty cool. So thanks a lot.